This is the 2022 2D array question. So on this one we have the class data. So we have a class data right here, and we have a 2D array called grid. Notice that we do not know the size of that. We're still going to have to make that. The grid is not null. Public void repopulate, and then count increasing columns. It wants us to know how many increasing rows there are. All right, so we want to repopulate this with numbers between 1 and max inclusive that is divisible by 10 and not divisible by 100. All right, so we're going to write repopulate. So public void repopulate. Nothing's being passed in. We're going to traverse our 2D array. So I'm going to do row major. It doesn't matter for this one. So int r equal to 0, r less than grid.length, r plus plus, and now we traverse our columns. So column equal to 0, column less than grid 0.length. That's picking up the 0th row and finding the length, which would be the number of columns. Remember, you want to think of an array as an array of arrays. So the big array would be like your rows, the smaller arrays are your columns, and everything in AP is going to be rectangular. So the next thing we have to do is actually calculate our random number. So int, I'm going to call it ran, and that's going to be equal to math.random. And then we're going to multiply that by the max and add 1. Remember, if you're doing a 6-sided dice, it'd be math.random times 6 plus 1. So always kind of think back to that base case. So now we have to make sure this is a value that we want to be able to, that we can add. We wanted it to be divisible by 10 and not divisible by 100. So we're going to keep getting random numbers while not both of those. So while our random mod 10 is not equal to 0, or our random mod 100 equals 0, then we have to reevaluate, create a new random number, because we're not in the cases that we need to be. Because if it was divisible by 10 and not divisible by 100, then we would add it. If it's not those, then you will have to regenerate. Once we have that one, we are going to add it to our grid. And then it'll go back, go to the next column until you're at the end of columns, it'll increment your rows. And this was a void, so nothing is returned. Part R. All right, so part A, repopulate. 1, you get a point for traversing with no error bounds. So 1 point right there. You got 1 if you generated a random number correctly. You get 1 point if you check the correct expressions that random needs to be either divisible by 10 but not 100. And then it correctly assigns all the things. So here, this is not an increasing row. This is not an increasing row. And actually by increasing rows, I meant increasing columns. So as I go down here, this is increasing, this one's not, this one's not. So this should return 1. Looking at the next one, this one's increasing, second column's not. Third column, I didn't read close enough, so I'm gonna wait a second. And the fourth one is also increasing. It says it should be 2, so this is not completely increasing if they're equal. The grid is not null. So count the number of increasing columns. So we're going to fix a column, traverse a row, so we're gonna have to do column major, and all we need to find is one element that does not increase, change our Boolean to false, and after we get through all the rows, if it's false, you're not gonna increment. If it is false, if it's true, then you would increment. So public int count increasing columns. So first thing, we have to instantiate the count. We're going to do a column major traversal. So grid 0.length. So each time we start a column, we're going to set our Boolean equal to true. So Boolean order, I'm just going to say increasing equals true. All we need to find is one place where it's not true. We'll change our Boolean to false. And then once we complete that column before we increment to the next one, we'll deal with our count, and then we'll go back and increase a column. So now looking at here, we're going to traverse our rows. So we're going to look and see if our previous element was bigger than our next element. So if grid RC is less than grid R minus 1 times C. Now I get a little nervous. As soon as you write minus 1 or plus 1, you have to go back and change things. So this has to start at 1 now because I can't look 1 back. The other thing you do is you can start the row at 0 and then you'll have R plus 1. So if this is true, our increasing is now going to be false because we found one place it was not increasing. After we go through all the rows, we're going to see if it's increasing. So if increasing, which is a Boolean, if it is, you're going to increment the count. Otherwise, you're not. And then you'll go back up here. You'll do your next column, go through the next thing, and finally return the count. So how was this scored this year? The second part, the first point comes from that you're doing column major order. You're comparing two elements in the same column. You determine if one column is increasing or not. You count the columns that it was increasing, and it returns the correct amount.